Liquid AI just unveiled something huge, their brand new model, LFM2VL. And honestly, it feels like we've just hit a turning point in AI. We're talking about a vision language model that doesn't just live on giant servers. It actually runs directly on phones, laptops, and even wearables. And here's the crazy part. It's already clocking in at twice the speed of the most powerful models out there. That means real multimodal AI, finally, right on your own device. Quick background on Liquid AI. But before diving in, let's talk about Liquid AI for a second. This company spun out of MIT's CSIL, one of the most respected AI research labs in the world, and instead of following the same path as everyone else, making transformers bigger and bigger, Liquid AI is doing something different. They're rethinking AI architecture from the ground up, pulling inspiration from mathematics and signal processing. The result? Their models, called Liquid Foundation Models or LFMs, are lighter, faster, and more flexible. And that philosophy of efficiency first really shines in this release, LFM2VL. What's new in LFM2VL? So what exactly is new here? LFM2VL is a family of vision language models built for low latency. In plain English, they're extremely fast and designed to run on everyday devices. There are two versions, LFM2VL-450M, 450 million parameters, super lightweight, made for devices where memory is extremely limited, LFM2VL-1.6B, 1.6 billion parameters, more powerful, but still compact enough to run on a single GPU or even a high-end mobile device. Normally, models this strong require massive server setups. This release makes that kind of power accessible locally. Why this matters: speed. Here's the exciting part: speed. Liquid AI claims their models run at up to 2 times faster inference speed on GPUs compared to other vision language systems. That's cutting processing time in half. And in practice, that's the difference between a laggy assistant and one that actually feels responsive in real time. How it's built now. Let's break down how LFM2VL is structured, because this is where things get interesting. It has 3 main components. 1. The language backbone, the brain for text. 2. The vision encoder, the brain for images. 3. The multimodal projector, the part that fuses text and vision together. For the 1.6B model, the backbone is based on LFM2-1.2B. For the smaller 450M version, it uses LFM2-350M. On the vision side, both use SIGLIP 2NLEX encoders. The large model uses a 400 meg parameter encoder for high detail. The small model uses an 86M encoder that's faster and lighter. And here's something clever. The models process images at their native resolution up to 512 by 512 pixels. If an image is larger, it's split into patches, so every detail gets processed without distortion. The 1.6B model adds another trick. It also looks at a small thumbnail of the entire picture. That way, it understands both the fine details and the big picture. Multimodal projector, the secret sauce. The multimodal projector is where the magic happens. It uses a method called pixel unshuffle. Basically, it reduces the number of image tokens so the model doesn't waste time on unnecessary details. For example, a 256 by 384 image, about 96 tokens. A 384 by 680 image, about 240 tokens. A massive 1000 by 3000 image, around 1020 tokens. The whole goal? Balance detail with speed. And here's the best part. You can actually adjust this yourself. If you're on a tiny device, prioritize speed. If you're on a stronger machine, crank up the detail. That flexibility is one of the biggest advantages of LFM2VL. Training process. The training pipeline is also pretty unique. Step 1. Pre-train the backbone on text. Step 2. Mid-training, where vision and language are slowly blended together. At first, it's 95% text, 5% vision. By the end, it's 70-30. Step 3. Fine-tuning for advanced image understanding. In total, they trained with about 100 billion multimodal tokens from both open datasets and their own synthetic vision data. Benchmarks. Does it live up to the hype? So, does it actually perform? On real-world QA, the 1.6 billion model scored 65.23, rivaling Intern VL3. On InfoVQA, it hit 58.68. On OCR Bench, it scored 742. The smaller 450 million model also pulled solid results, 52.29 on real-world QA, 655 on OCR Bench. And when it comes to inference speed, they're not just competitive, they're leading. In standard tests, these models ran up to 2 times faster than comparable systems when generating 100 tokens from a 1024 by 1024 image. That speed matters. If you're building a smart camera, phone assistant, or robot, shaving seconds off processing time can make or break the user experience. Ease of use. Another win, ease of integration. These models work seamlessly with Hugging Face transformers. They support quantization, so they can run in even less memory. And they're fully tied into Liquid AI's Leap platform, which works across iOS, Android, and more. There's even a companion app, Apollo, where you can test things completely offline. This is a clear push toward Edge AI, keeping computation on your device instead of relying on the cloud. That means better privacy, lower costs, and faster performance. Licensing. Now about licensing. The models are released under the LFM-1.0 license, which is similar to Apache 2.0, but with one condition. If your company makes under $10 million revenue, you can use it for research and commercial purposes. If you're bigger than that, you'll need a commercial license. So it's open, but designed to protect against giant corporations scooping it up for free. Use cases and the big picture. Liquid AI highlights use cases like real-time image captioning, multimodal chatbots, visual search, robotics, IoT systems, smart cameras. But the bigger story is this: AI is moving away from the cloud. Instead of needing massive server farms, these models show that powerful AI can run directly on the devices we already own. And that's where the industry is headed. AI that's private, fast, and affordable. That's everything you need to know about Liquid AI's LFM2VL. What do you think? Is this the future of on-device AI? Drop your thoughts in the comments. If you found this breakdown helpful, hit that like button, subscribe for more, and turn on notifications so you don't miss the next update. Thanks for watching.